Till now we have discussed arrangements and selections. Today we will discuss distributions. So find the number of ways to assign 100 different diplomats to different continents. So both diplomats and continents both are different. So of course each diplomat has 5 choices and it goes till 100. So the answer is 5 raised to the power 100. And if I say that if 20 diplomats must be assigned to each continent, then I can say there is type 120, type 220. So it becomes the problem of arrangement with repetition, and that is 20 factorial raised to the power 5. So how do we reach to this answer? So these are the basic models of distribution. When the process of distributing r distinct objects into n distinct boxes is compared equivalence to putting distinct objects in a row and stamping one of the n different box names. So if it's like 100 diplomats are there, you write, and to each one of them you, let's say first one is C1, the next one is C2, then C1, then C3, and so on, and that gives you the total possibilities, and which is n raised to the power r. And then the other case which we have discussed is if Ri objects go in box I, then it is the problem of arrangement with repetition. So let's try this question. How many ways are there to distribute 20 identical word has been used, but what we have just discussed, the distribution problem, it was distinct. So in case of identical, it becomes the selection with repetition. So when I say 20 identical and I have to select from 5 possibilities because 5 children are there, so 20 plus 5 minus 1, CR plus n minus 1 comma r, and similarly C 15 plus 5 minus 1 comma 15, which means that the process of distributing r identical objects into distinct boxes is equivalent to choosing a subset of all box names with repetition among n choices of boxes. So this is we have already discussed. So the important observation here is that distribution of distinct objects is arrangement and identical object is selection. Even this is what we have discussed till now. So NPR and NCR, unlimited repetition and arrangement, distribution of distinct objects, and raised to the power r, and the other two formula where we discuss the arrangement and selection with repetition. So let's try a few more questions. Number of ways to distribute 4 identical oranges and 6 distinct apples into 5 distinct boxes. So identical oranges, so C R plus n minus 1, R is the number of the oranges, so 4 and 5 is the boxes, and then n raised to the power r, so 5 raised to the power 6. And the other case says that each box get exactly 2 objects. So now we have to consider different cases. You can try this by yourself first. So 4 oranges are there and 5 boxes. So you can say that O, and then apples in the remaining. But the other possibilities is one box has oranges and one orange, one apple in 2 boxes, and then 2 apples, or I can put oranges in 4 boxes and 2 apples. So if we discuss each case one by one, so in the first case I need to know that which two boxes have oranges, so 5C2, and then in these two boxes I just put the oranges because they all are identical. But in the remaining one I cannot just directly put the apples because they are distinct, so that's why I have to call arrangement with repetition. And if it is clear, then I keep adding the cases. Now I need that which box has only oranges, then the remaining two boxes having one orange each, and then 6 factorial, 2 factorial, 2 factorial, 1 factorial, 1 factorial, and the last which 4 boxes have oranges, and then 6 factorial, 2 factorial, and if you want you can write 1 factorial 4 times. So this is the required answer. So there are few details if you want to see into the slides, but moving further, number of ways to distribute are identical balls into n distinct boxes with at least one ball in each box. So when it say at least one ball in each box, which means that we already put one ball in each box. So if there are n boxes are there, and if you put one ball in each box, the remaining balls are r minus n. So distributing r minus n into n boxes, so the formula we just replace r by r minus n, and if you simplify it, then it becomes c r minus 1 comma n minus 1. So you can simply remember this formula, and similarly you can generalize the second case and you can remember the required formula. So based on this, how many integer solutions are there to this equation? So if you see this one, then simply you can see that there are 4 boxes, x1, x2, x3, x4 and 12 identical objects need to be distributed to these 4 boxes. So to distribute them, we already know the formula, so it's c r plus n minus 1, so number of the balls are 4, and then the next one says that with xi greater than equal to 1, which means each box has at least 1, so which is c r minus 1 and n minus 1, so c 12 minus 1 and 4 minus 1. And the last one says that c r minus r1, so 10, sorry it's 12 minus 2 minus 2 minus 4 and then n minus 1, so 4 minus 1 and then n minus 1. So all three we have just directly used the formula, but the important observation is that finding the number of integer solution is same as distributing identical objects into different boxes. Okay, so one more question, how many arrangements of the letters, so A, E, I, O, U are distinct but X are similar, such that no vowels can be consecutive. So if I have A, E, I, O, U, since they are distinct, so they can be arranged in 5 factorial ways. But now I have to ensure that they should not be consecutive, which means I must put some x in between. So at least one x at these 4 positions. It means that I simply need to distribute 4 remaining x into 6 positions. So these are the 6 positions. So distributing 4x into 6 boxes, so c r plus n minus 1 comma r, which is the required answer. Okay, so last one, it says that what fraction of binary sequences of length 10 consist of positive number of ones, then zeros, then ones, and then zeros. So which means that there are type 1, type 2, type 3 and type 4, but they are identical, and there is a condition that each box should have at least one ball. So it simply becomes CR minus 1 and N minus 1. And if I have to find the fraction, it means the total possibilities, which is 2 raised to the power 10, because each position can be filled in two ways, 1 or 0. So this is what we have discussed in today's class. You can go through these slides, and that's all. Thank you.